Welcome everyone. This is Zahid Bashir. I am a faculty member in Department of Commerce, University of Gujarat, and I am a PhD scholar at Helly College of Commerce, University of Punjab. Today is the 15th day of our sessions on Stata, and previously we were discussing the case where T is greater than 25 and N is greater than 25. It means the time periods are greater than 25 and the number of countries are greater than 25. So what we have covered yesterday, we have covered a data set that fulfill this condition. And Vakar is asking, sir, can you explain little bit zero level and one level? How can we choose dynamic and other methods? Yes, I have discussed yesterday, but I will repeat today again. What is the meaning of zero level and level one? And how can we choose the dynamic correlation effects and common correlation effects? So don't worry, I will repeat both of things today. Yesterday, we have covered the scenario where we have applied, first of all, the declaration of our panel. Let's suppose this is the case. Yes, this one is the case that we have covered yesterday. Let me repeat this portion. First of all, we declare our data set to be panel, and then we considered applying fixed effect and panel effect, tooled OL as random effect, and we find out that fixed effect is a reasonable choice among the three models. Then we checked for cross-sectional dependency and we found that there is a cross-sectional dependence in our panel. After that, what we do, we considered panel unit root testing. There are two types of panel unit root testing when there is a cross-sectional dependence in your model. If cross-sectional dependence is found in your model, you need to apply the second generation unit root test like CIPS and CADF. But if there is no cross-sectional dependence found in your model, then you need to apply the first generation unit root test. It means in this case, as we have found that there was a cross-sectional dependence in our panel, so yesterday we have applied the second generation unit root testing using CIPS. And let me show you the results that we have created yesterday for our analysis. These are the results. If you missed the video, please see the video again, how I have generated these results. So what does it mean by zero level and what does it mean by first difference? Basically, level means when you take a model at without taking the first difference. That is the zero level. Let's suppose that this is the model. Y is equal to alpha plus beta into x1 plus beta 2 into x2 plus error term. Now, this is a simple model. If I take the regression on this, this would be called at zero level. The first level means that I am taking the first difference of my variables, like for example, alpha plus beta into x1 minus x1 plus beta into x2 minus x2 and so on. This is called the first difference. You take the first difference and you consider it as a first difference model where you take the first difference of each of your variable. It means that you subtract the value of your variable from each of the next value of your variable. So it is called the it is called the first difference. So these are the results of the first difference, and these are the results of level. It means if you do not take the first difference, these would be the normal result of your model. But if you take the first difference, it means these are the results of your model. So sometimes when we take the stationarity testing at level, it means without taking any difference. It may be significant, it may not be significant. But sometimes if it is not significant at levels, then we need to take the first difference, and it will normally make them stationary. So that is why we take the first difference of our variable to make it stationary at level at first difference. So according to our assumption, if we go to the finalization of model, this is this one you need to see. If you find cross-sectional dependence and you applied the second generation panel unit root testing, now there are the further two choices that you need to see. First, you need to see that if your dependent variable is stationary at zero level or at level, it means without taking the first difference. And your independent variables are also basically uh, stationary at level, then you are going to apply common correlation effect. And if your dependent variable is stationary at first difference, and your independent variable, some of them may be stationary at zero level or at level, or some of them may be stationary at first difference, uh, and some of them may be stationary at second difference as well. It means independent variable are giving the mixed results. In that case, we need to run dynamic common correlation effect. So always remember that you need to understand the scenario. So if we see our result like this, if we see our results, if you see, first of all, your dependent variable, our dependent variable is dv is fdi. This is our dependent variable. If you see the dependent variable, it is stationary at level as well as it is stationary at first difference. So we can say it is stationary at level as well as at first difference. At both terms, it is stationary. Preferably, we would say that it is stationary at zero level because it was stationary at this level. But if we see IVs in this case, if let's suppose we do not consider these two IVs, let's suppose our IVs are FD, CF, SEG, GP, PGR, inflation rate, and RGR. Let's suppose these are our IV. FD, CF, SEG, GDP, GR, inflation rate, and RGR. Now, let's suppose these are our IVs. So if you see only these IVs, if I highlight these, for example, in pink color. Yes. Let's suppose these pink color highlighted are IVs. Now uh, they are also stationary at zero and as well as at first level. Now, what model we are going to use based on these estimates? So if I would show you this picture. Now decide which model I am going to use, whether I am going to use common correlation effect or dynamic common correlation effect. Do you decide anything, Adnan Afzal and Bakar Muhammad here?
जी
Which model we are going to use, whether it is common correlation effect or dynamic correlation effect with this combination. Bakar said it is dynamic. What do you say is Adnan Afzal?
yes, it will be dynamic because it reveals different combinations of
No,
significance.
if we see only the FTI and the blue highlighted independent variables like FD, CF, SEG, GP, GDP, GR, inflation rate, and RGR, they are stationary at zero, as well as they are also stationary at first level. It means if we consider zero, because they are stationary at zero as well. So in that case, what should we do? We should consider, my interpretation here is that we should consider common correlation effect, because it says if your dependent variable is stationary at zero and independent variable are also stationary at zero, we should consider common correlation effect in that case. So if we are going with this combination, they are stationary at 0 as well as 1. So we prefer, first of all, the at level combination. So we can say here they are going with the common correlation effect. Now, what if I include the other variable also, like GDPPC and TROP? They are not stationary at level, they are stationary at first difference. Then our choice would be dynamic common correlation effect. Always remember. So, because in that case, we have the IVs with mixed effect, because some of the IV would be significant at zero level and some of the IVs would be significant at first difference. It means IV would be mixed, while DV, as we have seen that DV is already significant at zero and at first level. So in that case, we are taking, let's suppose I am taking this combination again here, and I am putting the other two variable like GDPPC, GDPPC and TROP. Now they are giving the stationarity at first difference only. They are giving first difference result. In that case, we can say that this combination, this combination is giving us mixed result, because in that case, some of the variable are stationary at first level and some of the variable are stationary at both levels. So we can say the combination of these variable would be giving us mixed stationarity or mixed unit root at different levels. Now, in that case, we need to consider our IVs with mixed stationarity and our DV obviously with 1, because this fulfills the second criteria, DV with 1 and IV with mix. In that case, we are going to use dynamic common correlation effect. So always remember, when your independent variable are stationary at zero level or at level, and your dV is also stationary at zero level, you are going to use common correlation effect. But when your independent variables are stationary at mixed level and your dependent variable are is stationary at first difference, then you are going to use the dynamic common correlation effect. Now, how can we use this? If I use the first combination, if let's suppose I would like to use this combination, how can I'm going to use the common correlation effect? That is the case. So what option do I have? Let me show you the command. This is the command which we are going to use for common correlation effect. Let me write here common correlation effect. This is the command we can use for common correlation effect, and this is used when your dV and IVs are stationary at level, means zero. So this is the command that we are going to use when our dV and IVs are stationary at zero level. But if IV and dV are stationary at mixed level, sorry, IV is stationary at mixed level, we are going to apply dynamic common correlation effect, and in that case, we either going to use this command or this command. So let me apply the first one. Here there is a note. If you use XTCCE, that is a common correlation effect command, and XT is an extension for panel data, as we are using the panel data. Therefore, to apply the common correlation effect, we need to write CCE. So if we write it without pooled option, if simply we write XTCCE with DV and IVs only, and we do not write pool, then you will get CCMG estimation. That is another estimator. So always remember that you need to write here the pool. So let me open my data set so that we can elaborate it. Uh, there is a Stata. I have shared the data set with you regarding our previous session. So let me open that data file again. That was the data relating to middle income countries. And I have shared this data set with the name of T and N greater than 25. This was the data set that I have shared with both of you. So this is the data set. I would like to show you first of all the number of countries which is represented by ID are 53 here, and the number of time period is basically, if you see here, starts from 1980 and ends on 2020. It is approximately more than 40 years. So this combination is applicable on our situation. So in the previous video, I have determined the panel unit root. So let's suppose we are going with the first combination, that is FDI and the variable highlighted in pink color. So all these are showing this combination, means DV is stationary at zero and first level, and IVs are stationary at zero and first level. So we are considering they all are stationary at zero level. So we are going to apply the common correlation effect. So let me show here the analysis. that is xtcce. This is the command that we are going to use. First, we need to write the dependent variable. Then we need to put only those independent variable which we have decided for this combination, like FDCF. What variable we are going to exclude? We are going to exclude GDPPC and crop. So do not write here the GDPPC and crop. Yes, this is the combination. We have not included GDPPC and crop variable. Now we need to write comma and then pool, because it is written in the command that you need to write this combination XTCCE, DV, IVs, and pool. So we need to run this command. This says that this command is unrecognized. So what we need to do, we need to write here SSC install XTCCE. So it will install this command, because whenever you apply a command for the first time in your Stata, it will unrecognize the command because this command is developed in the latest version. So the installation is complete. Now we are going to apply this command here like this. Panel variable not set, use xt set. All right. We need to consider xt set because we do not have declared this data set to be panel. Always remember that you always need to run this command whenever you are going to run the panel that FD made first. So it says that meta size is too small because the command is very heavy. It says that you have attempt to create a matrix with too many rows or columns, or attempt to fit the model with too many variables. You need to increase met size. It is currently 400. Use set met size. All right. Let we write here set met size equal to 1000. So let's see what will happen. Uh, I have write this command. Previously, the met size is 400. I have write here set met size 1000. And then again, I am going to run this command. Yes, the command is run here. Now you can see that it is very long estimation. This is a very long estimation it has created. It has basically created the estimation on all the countries that were available. So what if we are going to use this command without fools? So what will happen? So let's suppose this is the command. Yes, now it is showing a better result. But if you see this model is not significant here. It is generating the common correlated effect estimation with mean group OLS, but this is not significant here. So what do you feel here? The FD is weakly significant. It is significant at 12%. CF is significant. SEG is not significant. And if you see FDI, they have created a value of FDI here, FDCSA. They have created a lot of other variables too. So if I see the previous combination, the model was fit here. In this way, the model is fit. And if you see here, this is the initial estimate. Now, this one is basically the requirement art study. We do not need to take ID wise results, we need to take these results instead. This command is better one that we have previously run with pooled command. So you need to take only these results. So if you see here, the model is statistically fit and FD is positive and significant here. CF is positive and significant here. SEG is weakly significant. GDPR is not significant here. Inflation rate not significant. Exchange rate not significant here. So this combination is much preferred combination with this command. Now, let's suppose we are going to use the first combination like this one for applying the dynamic common correlation effect, because in that case our IV would be stationary at mixed levels with stationary at mixed level. In that case, we are going to run the dynamic common correlation effect. Now, what is the pattern of that command? This is the pattern. What we need to do, we need to write, previously we have written XTCCE for common correlation effect. Now we need to write XTDCCE2. That is basically dynamic common correlation effect 2. This is the latest version. That is why they are using the XTDCCE2. Now, how they basically run this command, they create first difference with dependent variable, and then they take the lag variable with dependent variable. Then they take the independent variable as well in the same pattern. So we need to run this command here. We can run without no cross and without cross. So let's suppose we are going to take, along with the previous combination, we are going to take the other combination to XTD CCE2. We need to write here XTD CCE2, dependent variable, independent variable, and we need to include here the other two variables that we excluded previously, like GD, PPC, and drop. Now, we need to see the pattern here. The pattern is that we need to write D dot with dependent variable. First we need to write the D dot that creates the first difference of our dependent variable. Then what is the next? The next thing is that you need to write L dot with dependent variable. That creates the lag of your dependent variable here. So we need to write here our dependent variable, which is FDI, and write here L dot with FDI. Now, if you see this command, this shows first difference with dependent variable and a lag with dependent variable. And if we compare this command with this combination, XTDCCE2, first difference with dependent variable, lag with the dependent variable, lag with dependent variable, and then independent variable. And first we run this one without no cross combination. So the command is complete. We just need to run it and we will see. They are asking that we need to write here no cross sectional. All right. This command is basically run with no cross only. So we need to run this command. Basically, it is not accepting this command. So we only can run this command. So here we need to copy our previous commands, not this one. we need to copy this command, our latest command, which was not executed here, like this. Place comma and no cross. Basically, it will exclude the cross-sectional dependency. No cross. No cross. Yes, it is used for excluding the no the cross-sectional dependency. So if we apply this, it is run. If you see the title of this command, that is dynamic common correlation estimator. So this is dynamic common correlation estimator. The model is fit. If you see, this is less than 5%. The R square is 45%. And if you see the results, the lag of FDI is negative and it is statistically significant. And if you see the FD is not significant here. CF is not significant here. SEG is not significant here. GDP growth rate not significant. GDPPC not significant. Crop is significant. If you see these two variables, it is weakly significant and it is also significant here because these two were the variable which are causing the stationarity issue. So what we need to do, we need to create the first difference because our analysis indicate that this command is basically used when your independent variable are showing the mixed unit root. So what we can do here, we can basically create another combination with first difference command. So let me include first difference with all my independent variable too. D dot CF, D dot SEG, D dot GDPGR, D dot GDPPC, D dot EROT, D dot inflation rate, D dot exchange rate, and D dot real growth rate. I have included the first difference with all my independent variables to make it more suitable. So let me run this command. If you see here, what changes have you noticed here? You can see here that the F statistic is significant and R square is increased here. Previously, the R square was 45%, and now the R square has increased to 57%. And the second thing, if you notice here, a lot of your variables become significant. It is still not significant. The CF is significant at 5% level. It means your capital formation using first difference is significant. D significant is not here. If you see GDPPC, it is significant. It is highly significant. Trade openness is also significant. And if you see inflation rate, it is significant, weakly significant at 10%. So a lot of variables has significant here. So you can again try with different combination. You can include another D here or 2D here. For example, if I would include here 2D or second D combination, 2D, 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 2D. You just need to write 2 here. And if it does not work, we need to include second D here. Let me check whether 2D works with this command. 2D operator invalid. It means we need to write another D here. T T T and T like this. If it works, then okay, we will be able to find out more better results. Yes, this command works. So if you see the results, the R square somehow decrease, but the results are not better. It means the previous commands is acceptable because here the R square is better and the results with some of the variable is significant here. So this is dynamic common correlation effect. With this combination, you can apply it. Another thing that I would like to let you know, and I would like that you should practice that command, that is CADF test. Because previously I have given you stationarity results with CIPS. If you see this table is created based on CIPS. You can create another table with the second option that we have available with the second generation unit root test is CADF test. That is another unit root test. And if this unit root test can be used to check the stationarity of the data having cross-sectional effect. So first of all, uh, uh, you need to consider this one. You need to install this command ssc install PESCADF, that is Pasran uh, Pasran ADF test. So you need to install this one because if you are going to use this for the first time, you need to install this command. So it is checking the consistency and verifying not already installed. So once it is installed, then you can use this command. So what is the combination of this command? You always need to use at level first. So you need to put this command here like this. And you need to replace the var variable. For example, if I am going to take the stationarity of FDI at lag 0 trend, I can run this command, and if you see the p-value, you can here you can decide on the p-value. If p-value is 0.000 and it is less than 5%, it means it is stationary. It is stationary at 0 level, and you need to put this value, t bar value, and you can place it here. You can create another segment on the right side like this. This is CADF, and you can place here at level. And in the same way, you can place another bar here, and you can check for this command d dot var. You can include d dot. So the time for today's session is going to end. Do you have any